Good morning, students. Today we are going to see exercise 7.8, the problem number 5. Okay, a rectangular page is to contain 24 centimeters squared of print. The margins at the top and bottom of the page are 1.5 centimeter and the margins at the other sides of the page is 1 centimeter. What should be the dimensions of the page so that the area of the paper used is minimum? Okay, you see now first sentence, a rectangular page is to contain 24 centimeters squared of print. So you will have the page is in the shape of a rectangle. So on that page, the page contains 24 centimeters squared of print. That means you can print the matter whose area is 24 centimeters squared on this page. So here I have marked the printed area in blue color rectangle. So the area of the printed part is 24 centimeters squared. So this area is given. For that I am going to take the dimensions of the printed area on the page. So first dimension is x, another dimension is y. So this is your x and this distance is y. Be the dimensions of the printed area. What is given? The printed area is equal to 24 centimeters squared. So the printed area is in the shape of a rectangle. So we can write length into breadth. So it is x into y is equal to 24. So from the given result, you have to write one variable in terms of another one. So y is equal to 24 by x. You see that here the margins at the top and bottom of the page are 1.5 centimeter. So on this page, the top margin is 1.5 centimeter as well as from the bottom the margin is 1.5 centimeter. The margins at other sides of the page is 1 centimeter. So these two sides the margin is 1 centimeter. Okay, see what is the question has asked you. See what should be the dimensions of the page. So we have to find out the dimensions of the page. That means this length as well as this length you have to find out so that the area of the paper used is minimum. So this area of the whole paper is minimum. Okay, so this is the result you have to find out. So from the given result we have written that. Next you have to see which should be maximum, minimum. So see here, area of the paper is minimum. So area of the paper means the whole page including margin and the printed area, everything has to be considered. Okay, see that from this distance to this distance is x. Okay, the whole page length is starting from here to here. Okay, so this distance is x. So you have to move here 1 centimeter, here from here also 1 centimeter. So this length is x plus 1 plus 1. So the length of the page is x plus 2. Okay, you see now. See the blue color from here to here is x. So now we are going to find the area of the paper is minimum. For that we need the dimensions of the page or this paper. So we need this length. So from here to here is x, isn't it? So we have to move 1 centimeter from the right as well as 1 centimeter from the left. So therefore the total length is x plus 1 plus 1. So the length is x plus 2. In the same way, this distance is y. So above you have to move 1.5 centimeter and below also you have to move 1.5 centimeter. Then only you will get this dimensions of the page or the paper. So y plus 1.5 plus 1.5. So it is y plus 3. So the whole page or the whole paper dimension is x plus 2 and y plus 3. So here I have written, let the dimensions of the paper be x plus 2 and y plus 3. So what is asked? The area of the paper is minimum. So we have to find the area of the page or area of the paper. So what we have to do, that also, that page is in the shape of a rectangle. So we have to multiply length into breadth. That is x plus 2 into y plus 3. Okay. So x into y is xy. X into 3 is 3x. 2 into y is 2y. 2 3s are 6. So it is given already. What is xy? Xy is equal to 24. So in the place of xy you have to substitute 24 plus 3x plus 2 into, what is your y? Y we have found as 24 by x. So in the place of y I have substituted 24 by x plus 6. Okay. So your f of x is equal to, what is it? 30 plus 3x plus 48 by x. How the 30 has come? 24 plus 6 is 30. Okay, ma'am. So we have found everything is in terms of x. So it has to be taken as f of x. What is f of x? Area of the page or area of the paper. So what we have to prove? This should be minimum. So we have to use the second derivative test. First step, you have to differentiate f of x with respect to x. 30 is a constant. It will become, the differentiation is 0. 3x differentiation is 3, and here it is 48 is a constant. The differentiation of 1 by x is minus 1 by x square. So you are getting 3 minus 48 by x square. What will be the next step? You have to equate to 0. So 3 minus 48 by x squared is equal to 0. This minus 48 by x squared, when you take it to the next side, it will become positive. So 48 by x squared is equal to 3. So 48 by 3 is equal to x squared. So x squared is equal to, when you divide it, is 16. X is equal to plus or minus 4. So it is a length. So length cannot be negative. So therefore x is not equal to minus 4. So x is equal to 4. After finding x, you have to go to the second derivative. So you see the first derivative is here. So if you differentiate this again with respect to x, the differentiation of 3 is 0. Okay, here minus 48 I have written. So here you are having 1 by x square. We have to differentiate 1 by x square. First you bring it to the numerator, x power minus 2. When you differentiate x power minus 2, the answer is minus 2 into x power minus 3. So that will be written as minus 2 divided by x cube. So minus 48 is already there. So minus 48 into minus 2 is 96. 96 divided by x cube. What you have to do? This point has to be substituted in the second derivative. So f double dash of 4. You see now, f double dash of 4. What is it? It is 96 by 4 cube. So what is it? Numerator and the denominator both are positive. So it is greater than 0. If it is greater than 0, the function is, what is it? Minimum. What is the function? The area of the page or the area of the whole paper is minimum when x is equal to 4. Next, what you have to find? Y. Y value is what? 24 by x. So 25 by 4, that is equal to 6. You see the question, what is asked? What should be the dimensions of the page? Okay, so the whole page dimensions, though that means x plus 2 and y plus 3, not x and y. X and y are the dimensions of the printed part only. Okay, so here it is asked the dimensions of the whole page. So the dimensions of the whole page are x plus 2 and y plus 3. So x value is what? 4. So 4 plus 2 and y value is 6. 6 plus 3. So therefore 6 centimeter and 9 centimeter. Okay, so we'll come to the problem number 10. A manufacturer wants to design an open box having a square base. A manufacturer wants to design an open box having a square base and a surface area of 108 square centimeter. determine the dimensions of the box for the maximum volume. Okay, you see that what is given, surface area is 108 square centimeter. Box order surface area is 108 square centimeter, and we have to prove maximum volume. The box should have the maximum value. When the box has the maximum value, you have to find the dimensions of the box. That is the question is asked. Okay, so how the box should be? It has a square base. You consider this box. Okay, you see that it has a square base, and you see surface area is given. So see, now it is a open, what is that? Wants to design an open box. Okay, it is a open box. You see now square base. So we have to find the dimension. We have to mention the dimension. So this is x is the, what is that? Length of the square base. X is the length of the square base. So this also x, here also x, here also x. So this x. So the square base, adoda length is x. And next dimension, y be the height of the box. Y be the height of the box. You see that this is the height of the box. Okay, ma'am. So you are having two dimension. One, x is the length of the square base and y is the height of the box. So we have taken that. Let x be the length of the square base and y be the height of the box. Here the base is shaded. So this distance is x, here also x, this also x, this also x. So this is y, here also y. So that I have shown through this box. Okay, what is given about the box? Surface area is 108 square centimeter. You see that you will have, you see, bottom, it's a square. So what is the area of this square? We have taken the length is x. So the area of the square is x squared. So one surface we have found, that is the bottom surface we have found, whose area is x squared. And you see, take this surface. Okay, you see that part. Okay, so here you see it is in the shape of a rectangle. So what is the length? Length is x. And what is this distance? It is nothing but y. So the area of one side of the box is x into y. How many sides it has like this? 1, 2, 3, 4. Isn't it? So therefore, the area of the 4 sides is 4 into xy. And see the above, it is an open box. So we are not going to consider the top. We are going to consider only the bottom and the 4 sides. Isn't it? Okay, so that's why I have written x squared. X squared is nothing but area of the bottom. That is in the form of a square. And what is 4xy? So xy is the one side area. That is, here you are having 4 sides, so therefore 4 into xy. So the total surface area of the box is 108. So from that, 4xy is equal to 108 minus x squared. So from the given result, what do we have to do? We have to find one variable in terms of other. So therefore, y is equal to 108 minus x squared by 4x. So one part is over. Next, you have to see which should be maximum and minimum. So see that, determine the dimensions of the box for the maximum volume. So we have to find the volume of the box should be maximum. So for that, first you are going to find what is the volume of the box. Okay, so how it should be? It is length into breadth into height. What is the length? X. What is the breadth? That also x, because it has a square base. And what is the height? It is y. So therefore the volume of the box is x into y, that is x squared y. Okay, x squared. Y has to be substituted. That is 108 minus x squared divided by 4x. So 1x getting cancelled. So x into 108 minus x squared by 4. Okay, so 108 by 4 is 27 into x minus x into x squared is x cubed by 4. So this is your, what is it? F of x. Why? It is fully in terms of x, so we take this as f of x. What is f of x now for this problem? It is nothing but the volume of the box. So we have to show that this volume should be maximum. For that we have to go for the first derivative, f dash of x. So 27x is there. So 27 is a constant. The differentiation of x is 1. And minus 1 by 4 is a constant. Okay, we have taken out x cube. If you differentiate, it is 3x squared. Next step, you have to equate to 0. So 27 minus 3x squared by 4 is equal to 0. So 3x squared by 4 is equal to 27. X squared is equal to, what has to come? 27 into 4 divided by 3. So 3 and 27 getting cancelled. So it is 9. 9 into 4 is 36. So x is equal to plus or minus 6. So x cannot be equal to minus 6. Why? X is nothing but the length. So x is equal to 6. Next, after finding x, what you have to do? You have to find the second derivative. You see the first derivative here, 27. The differentiation of 27 is 0. And minus 3 by 4 is a constant. If you take it out, what is remaining? X squared. So the differentiation of x squared is 2x. So your answer is minus 3 by 4 into 2x. So that is minus 3 by 2 into this 2 and 4 getting cancelled. So minus 3 by 2 into x. So what you have to do? You have to substitute x value. What is x value? We have found it is 6. So when you substitute, so this term 2 and 6 is getting cancelled. So here you are having 3. Minus 3 into 3 is minus 9. How is your minus 9? It is less than 0. So therefore the function is maximum. What is that function? Volume of the box. So volume of the box is maximum when x is equal to 6 centimeter. Okay, next you have to find y. What's the need to find y? In the question, what is asked? Find the dimensions of the box when the volume is maximum. So dimensions mean we have taken x and y. So x is found already. So we are going for y. So y can be written as, already we have found as 108 minus x squared by 4x. In the place of x, you have to substitute 6. So it is 108 minus 6 the whole squared is 36 divided by 4 into 6. 108 minus 36 is 72 divided by 24, that is equal to 3. So the dimensions of the box are x is equal to 6 centimeter and y is equal to 3 centimeter. Then only the box has the maximum volume. Okay, come to the problem number, what is it? 12. A hollow cone with base radius a centimeter and height b centimeter is placed on a table. Okay, show that the volume of the largest cylinder that can be hidden underneath is 4 by 9 times volume of the cone. Okay, see the volume of the largest cylinder that can be hidden underneath this 4 by times volume of the cone. Okay, you see that here the cone is drawn. Okay, so for the cone, what is given? Base radius is a centimeter. So from here you see that BC is equal to a centimeter. That is the base radius of the cone. And height of the cone, what it is? B centimeter. So AB, this distance is, what is it? B centimeter. What is AB? AB is equal to B centimeter. You see now, this is the base radius. Which is the base radius? BC is the base radius of the cone. That is given as a centimeter. So base radius of the cone is a centimeter. And height, what is the height of the cone? That is AB. That is equal to B centimeter. Okay, and cylinder, where it is? Cylinder is, it is hidden inside the cone. Okay, the whole cylinder which is hidden inside the cone, both is kept on the table. Okay, see now the pink color I have drawn the cylinder. For the cylinder also you will have the base radius. What is the base radius? We have taken BE is equal to R centimeter because it is not given about anything about cylinder. So we have to take the base radius of the cylinder B r centimeter, and the height of the cylinder, you see that the height of the cylinder, what it is, B to F or FB, that also we have to take as H centimeter. What is A? A and B are nothing but base radius and height of the cone. It is given to you. And regarding the cylinder, we are considering what is r centimeter be the base radius of the cylinder and height be h centimeter. So from the diagram, you see BC is equal to A and AB is equal to B is given for the cone. And these two terms we have taken. BE is equal to R and FB is equal to H. Okay, you see now nothing is given, so only the base radius and height is given, so we have taken this. Show that the volume of the largest cylinder, so we have to show the volume of the cylinder is maximum. Now we are going to take what is the volume of the cylinder. You see that volume of the cylinder is what? It is pi r squared h. Here r is the base radius and h is the height. Both the variables are here. So what we have to do? We have to convert h in terms of r or r in terms of h. Okay, we have to make it as a single variable either in terms of r or in terms of h. So here what I am going to do is I am going to change h in terms of r. So for that, from the diagram I am going to consider two triangles. One is a bigger one. What is it? ABC. I have drawn here separately. And another one, the smaller one, which I shaded with green color. So DEC. Okay, DEC. Both the triangles are similar. So first we will write the measurement. What is BC? BC is nothing but the base radius of the cone, that is A. And AB is the height of the cone, that is B. And DEC, listen here, DEC carefully. So BC is equal to A and BE is equal to R. Now what is needed? EC. So the whole distance A, from that you have to subtract R. So EC is equal to A minus R. And see DE. DE is equal to FB. What is FB? It's the height of the cylinder, that is equal to H. Okay, so they are similar. So we have to equate the ratios. Okay, so first AB by DE, which is equal to BC by EC. You see that? Here I have written AB by DE. AB for the first bigger cylinder. The same side I have taken for the smaller triangle. Okay. Now AB by DE, which is equal to, what is it? BC by EC. BC by EC. So we have taken these two results. What is AB? AB is nothing but, what is it? It is height of the cone, that is B. So I have written here it is B. What is DE? DE is nothing but the height of the cylinder, that is taken as H. So B by H is equal to, what is BC? BC is nothing but the base radius of the cone. So the BC is equal to A. Okay, and EC. EC is nothing but, you see here, BC minus BE, that is A minus R. So here it is A minus R. So what is needed? We need H. So H is in the denominator. So just reciprocate it. So H by B is equal to A minus R by A. H is equal to, this B will go to the numerator. So B by A into A minus R. So here B and A are given. So they are treated as constant. R is a variable. So volume of the cylinder, this only we have to show a maximum. For that, so I have taken pi r square h. In the place of h, I am going to substitute B by A into A minus R. When you simplify, pi B by A is a constant. r squared into a is a r squared minus r squared into r is r cube. So we have written this term in terms of r. So I have denoted as f of r. What is f of r now? That is the volume of the cylinder in terms of r. So what you have to show? That should be the largest. So we have to go for the second derivative test. So first you have to differentiate with respect to r. Pi b by a is a constant. A is also a constant. R square differentiation is 2r. And r cube when you differentiate it is 3r square. So next step you have to equate to 0. When you equate to 0, and the whole constant, when you take it to the next side it is 0. So 2ar minus 3r squared, which is equal to 0. From these two, what is common? R is common. So r, if you take it out, what is remaining? 2a minus 3r is equal to 0. R is equal to 0. What is r? R is nothing but the what is it? It's a base radius of the cylinder. R cannot be 0. Okay, it is not possible. R cannot be 0. If R is 0, the volume of the cylinder is 0. So R we are not going to consider. So next one, 2a minus 3r is equal to 0. So 3r is equal to 2a. R is equal to 2 by 3 into a. We have found the point. Next we have to find the second derivative. Go for the first derivative. What is it? This is your first derivative. Okay. So in that, pi b by a is a constant. We have to differentiate. So with respect to r, so 2a is a constant. The differentiation of r with respect to r is 1. And minus 3 is a constant. R square differentiation is 2r. So therefore, your f double dash of r is equal to pi b by a into 2a minus 3 into 2r. So that is 2a minus 6r. Next you have to substitute this point. When you substitute in the place of r as 2a by 3. So 3 and 6 getting cancelled. So here you are having 2. 2 2s are 4. So 4a. 2a minus 4a is minus 2a. So when you simplify this a getting cancelled, you are having minus 2 pi by b. How it is? Here you are having minus. B is a, what is it? It's a height. Okay, so it cannot be negative. So here you are having minus. So the whole term is negative. So the function is maximum. What is the function we have taken? Volume of the cylinder. So the volume of the cylinder is maximum when r is equal to 2a by 3. In the question, what is asked? You see that we have to show that the largest volume of the cylinder is 4 by 9 times volume of the cone. Okay, 4 by 9 times into volume of the cone. So we have to find what is the maximum volume of the cylinder. Okay, see now the maximum volume of the cylinder. So where it is? So here you see now this result. Here only we have written. So we either you can take this step or we can go for this step. Okay, so here h is h, otherwise we have to substitute what is h, then you have to substitute in this result. Either any one of the three steps we can take. So I have taken the middle step, pi r squared b by a into a minus r. In that, in the place of r, we have substituted 2a by 3. Then only when r is equal to 2a by 3 only the cylinder volume is maximum. For that, you see now, so it is pi r squared. So 2a by 3 the whole squared into b by a into a minus r, that is 2a by 3. Okay, so see now when you square it is 4a squared by 9 into b by a. So when you take LCM, 3a minus 2a by 3. So 3a minus 2a is a by 3. Okay, see now this a and this a getting cancel. So 4 by 9 we need, so we'll take it out. So here you are having the constant 3 in the denominator. So it is 1 by 3. Pi also here. So it is a squared into b. Okay, 4 by 9. This is what? It's a volume of the cone. What is it? 1 by 3 pi r squared h. Here your r, base radius of the cone is a. and h is b, height of the cone is b, so therefore 1 by 3 pi a squared b. So we have proved, or we have showed that maximum volume of the cylinder is equal to 4 by 9 into volume of the cone. Thank you, students.